Hello. Right. I think we are live and we are working. I'm going to just give it about a minute, 30 seconds to see if we get some more people, some late comers joining us on the webinar. So I know some of you are already there, but we'll just give it another minute or so just to make sure people are here, and then we'll get started. So already got viewers coming in, which is always quite exciting. This is our third Orchard OCD conversations, and each time we're building the viewers up. So we'll try and get as many people as we can to join in the next 30 seconds or so, and then we'll start proper. And we've got a great guest today, so really looking forward to chatting to her. I think you know the name if you've seen on Instagram. If you're here, you probably would have seen that. Amy Milton will be speaking to in just a moment. I'll just make sure I've got my setup right here. Okay, I think I'll get going. Hello and welcome to the OCD Conversations, a series exploring new and innovative ways to treat obsessive-compulsive disorder, from psychedelics to psychotherapy, deep brain stimulation to ultrasound stimulation, as well as repurposed medications and even computer games. We'll get onto that later on in the series. And I'm going to be pricking the brains of groundbreaking people who are pushing the boundaries when it comes to OCD treatments. We're really privileged to hear from some of the world's leading specialists who are transforming the way we view and tackle a condition the World Health Organization classifies among the top 10 most disabling illnesses globally, and which affects around 70 million people worldwide. I'm Sean Fletcher. I'm a mental health campaigner. I'm also a broadcaster. If you live in the UK, you may have seen me on the BBC or ITV. If not, you won't have seen me there, but I am a mental health campaigner who has, I suppose, first-hand experience of OCD in terms of my family. So OCD has affected my family. So I know how debilitating, how destructive OCD can be. Today, I'm joined by Professor Amy Milton. She's a professor in behavioural neuroscience at Cambridge University, where she leads the Memories and Neuropsychiatric Disorders Lab. And she joins me now. So let's bring her in. Hello, Amy.
Hello.
Brilliant. It's always good when the technology works, because I know you're there standing in the green room effectively, and I press the button and there's always a delay. Never sure where you're going to make it. Really good to have you here, and thank you, because I know you're really busy. You're doing loads of really good work, so good to have you here. We're going to be talking about your work on glutamatergic treatments for OCD. Now, we have a range of viewers and listeners, Amy. Some of them, I'm sure there'll be experts who are going, well, I know exactly what it is. I don't need to be told. But there'll be others, ordinary people like me, who will hear the word glutamatergic or glutamate, and it sounds very complicated. Can you just explain what those sorts of treatments, glutamate treatments, are?
Yeah, absolutely. So first of all, thank you for the invitation. I'm really excited to be here. So glutamate is one of the major chemicals that the brain uses to signal. So we have what we call excitatory neurotransmitters and inhibitory neurotransmitters, which are GABA and glutamate respectively. Glutamate is kind of like pushing on the gas pedal, and GABA is a little bit like pushing on the brake, if you want to have an analogy to a car. And we know in OCD that in certain brain regions, there seems to be kind of too much gas. There's too much glutamate in some of these regions as compared to the amount of GABA. And so we've been really interested in trying to target that kind of excessive glutamate to try and develop new forms of treatment for OCD.
So just putting OCD aside, so for me, I haven't got OCD. Are you saying that me starting this podcast, this webinar, I'm using glutamate, my brain's using glutamate to inspire me to motivate me to do stuff? Is that what you're saying? And then when I finish and I want to sit down and have a cup of tea and relax, the GABA is turning all those things off?
Well, it's all kind of in balance all of the time. So your major chemical for signaling anything, one neuron talking to another within the brain, is glutamate. And GABA, which is kind of our brake chemical, keeps things under control. But of course, the brain is complicated. There are lots of other chemicals that influence the way in which different circuits are working relative to each other. But yeah, glutamate is perfectly natural chemical that we're all using all the time. Our standard excitatory neurotransmitter.
So what has been found then? You're saying that someone who's having OCD is really affecting them at that particular moment, there is too much glutamate.
In particular brain regions. So, of course, we know that OCD is associated with both obsessions and compulsions. And we've been particularly interested in compulsions, particularly from our perspective, compulsive checking. Now, we know that compulsions develop out of essentially habits. Habits in and of themselves are not necessarily a problem, but when they become uncontrolled, then they can become compulsions, and then they do become really, really problematic. So we know a lot about the brain circuits that support habits and compulsions. And what we're seeing in OCD, or what's been reported in the literature, is that some of the brain regions that are really important for supporting habits seem to have too much glutamate within them. So there's too much glutamate signaling in those regions, which is making those regions dominate brain processing, dominate behavior in a way that isn't helpful for the person with OCD.
So that's the washing machine sort of, you go around and you keep doing the same thing rather
Yeah.
than saying I've done enough. There's an urge to keep doing that because there's too much glutamate, and there's an imbalance, basically.
Exactly. There's an imbalance between the go and the stop signals, and these habits just keep going round and round again.
Is that right across all OCD or just certain types of OCD?
So we think that fundamental mechanism is probably common across types of OCD. But of course, the details of particular compulsions will vary from person to person. But that kind of common final compulsive pathway, we think the circuitry is quite shared.
I mean, this is actually, every time I do interviews on the OCD conversations, the sort of detail, the fact that you're talking about the brain in this way, and I know you've simplified it to make it accessible to someone like me, but that's, I mean, you're doing this every day, so I suppose you take it for granted. It sounds absolutely mind-blowing, literally mind-blowing, what you're talking about, this idea of an accelerator and a brake, and that actually we can see when OCD compulsions are taking hold, the accelerator's on too much. Do you ever sort of wake up and think, wow, this is amazing? Or is it just because it's your everyday work? It's just it's one of those things.
I think that's one of the really nice things about working in a university, is that you get to work with students. So actually, when you're talking to the general public and talking to students, you do get these kind of washes of, oh yeah, actually this is really cool, because otherwise you get kind of bogged down in the daily grind of getting through the research. But yeah.
So let's talk about your modeling of it. So the rat model, you're testing this on rats, aren't you? Can you explain a bit about that?
Yeah, so what my lab is trying to do is to capture and model processes that are relevant to mental health conditions like OCD. Of course, I wouldn't claim that any of my rats have OCD. I have no insight into whether they would have obsessions. I don't even know how we would measure that. But what we can look at is sort of compulsive behavior in animal models. So what we've got is a task that was originally developed in the lab of Trevor Robbins by my colleague Dawn Eagle, which we refer to as the observing response task. And essentially what we're asking the animals to do is to work for sugar pellets. So we start them off on a very easy version of the task where they're just pressing levers to gain sugar pellets. It's all very good. But we make that task progressively harder and harder and more uncertain. So when they're on the full task, essentially, they've got very little idea out of the two levers that we present them with, which one is actually going to give them sugar pellets, because the link between the lever press and the sugar pellet is not that clear. They have to respond a lot of times to get the pellet. And the correct lever changes unpredictably through the session. So it's a lot of uncertainty on this task. I mean, basically, it sounds like it's impossible. So what we do to help them out is we give them access at the back of the box to another lever that we term the observing lever. And pressing that lever doesn't give them any reward, but it does give them information. So if they press that lever, it will put a light on above the lever that's currently the correct lever. So just for a few seconds, but it's enough information that most rats doing this task will use that observing lever to gain that information and work on that lever until they think that things might have changed again, and then they'll go back and check again.
So they're randomly doing it, and then they realize, oh, if I do that, that's going to get me the sugar pellet. So
I get
learn
information. Exactly. So the majority of animals use the lever in a really adaptive way. I don't know what I'm meant to be doing. I'll press this lever, I'll guide my responding, and then I work for my sugar. But there's a subset of animals that we've noticed that seem to spend a huge amount of time pressing that observing lever. So they keep going back. And in fact, they keep going back even when that doesn't have any consequence. So if they press it once, they get the light to come on. If they press it while the light is still on, nothing else happens other than us recording that. So they don't get the light for longer. They don't get any sort of additional information, or they don't get any reward. They'd be better off turning around and going and working on the levers that give them the sugar pellets. But we found time and time again that there's this subpopulation of animals that we can screen for in advance, and we can identify them in advance, that seem to spend a lot of time checking on this lever in a way that doesn't really help them on task. So it's those animals that we're particularly interested in from the perspective of OCD, because they're not using that lever in a way that's providing information, or in fact, for any real purpose at all. They just seem to be pressing it for the sake of it, and they keep going back and checking again.
So could you say they have got OCD, rat OCD?
I wouldn't go so far as to say they have rat OCD, because I certainly can't infer any obsessions in these animals. But we have found in sort of various experiments that we're writing up for publication at the moment that they seem not to be affected by changing the contingency between the checking and the light. So that's a standard test for habits, and they don't seem to be affected by that. And we found in a small proportion of animals that even if we punish them for checking, they will continue making that behavior. So that's very small population, I would say, are compulsive.
So that's the equivalent of someone who washes their kitchen surface, and as most people would say, oh, that's clean now with bleach or whatever. But someone with the obsessive compulsive disorder around cleanliness and contamination might then do it another 10, 20 times, and it becomes debilitating because they don't go out and they don't do things, or they maybe overwash their hands.
Yeah,
that's the equivalent in the rats. You're sort of saying it's not helping them anyway, but they're still pressing this lever.
Yeah, it's not helping them in any way, and they're still pressing. And then for an even smaller population, even if there's a negative consequence, even if there's adverse effects from continuing in this behavior, you carry on anyway. So it's like they can't stop.
What is that? Just like a buzzer or
so it's some very mild electric foot shocks, which sounds terrible, but it's very, very mild. It's a tingle on the hand if you test it yourself.
Yeah. So where do you go from here then to the work you're doing then?
Yeah, so we have our model, and so that then gives us a platform where we can test medications, particularly sort of new medications that it wouldn't be ethical necessarily to take straight into humans. But the work that we've done recently, and we published recently in Psychopharmacology, was actually looking at drugs that target glutamate receptors, at least one of which has actually been through clinical trials for schizophrenia. It was dropped by drug companies because it didn't have effects on psychotic symptoms, but it has actually been through safety trials. We know that it is safe to use in humans. So we're kind of looking at repurposing old medications that haven't gone any further, in this case for schizophrenia.
And that's really, really important, isn't it? Because it takes absolutely ages to get drugs over the line in terms of use in humans. So that saves you loads of time, does it?
Yeah, absolutely. We know we're not investing loads of effort into a drug that then is going to fail in tox screening and we can't give to people for whatever reason. So so we decided to focus on the glutamate system for the reasons that we were just talking about. We know that there are changes in the balance between glutamate and GABA in the brains of people with OCD, and particularly in the brains of people with OCD who are checking. So that's some really beautiful work from Trevor Robbins' lab. You can actually measure levels of glutamate using clever functional imaging techniques as people are engaged in the checking task, and you see increased glutamate in the brains of people with OCD while they're checking.
And that's the same with the rats then, is it? Is you using this? Take us into the next stage with the model that you have then.
Yeah. So we haven't directly tested the glutamate in the rats, although we could. That is a study that we should probably do. But essentially what we were reasoning was, we know that there's this increased glutamate within particular brain regions in patients with OCD. We've got our checking model. So what would the impact be of using these drugs that target the glutamatergic system on our model? So we used two different drugs, both targeting glutamate receptors. Now, it might be the case that your listeners have heard about Carolyn Rodriguez's really nice work with ketamine. That's working on the same system, but in a slightly different way. So if we think about how glutamate is used to signal between brain cells, you essentially have release of a chemical from one brain cell, and that's detected by another. So one gives out a signal and one receives that signal. So what ketamine does is it blocks that signal being received. So it acts on the second neuron to stop that signal from getting through. The drugs that we're looking at are actually acting on the first neuron to reduce the amount of signal that's being released in the first place. So they're, in technical terms, they're agonists and positive allosteric modulators, mGluR2s. So for those of you in the know, that's what we're doing.
I prefer the first explanation. That sort of registers a bit more with me. But
yeah. So essentially what we're trying to do is block or reduce the amount of glutamate release by using these drugs. So what we did was we trained up the animals on our model. We characterized who our high checkers were. And then we administered these drugs a couple of hours before a session, where we then put the animals back into the box and looked at their levels of checking. And what we found for both of these drugs, we did sort of a dose response curve. And what we found for both of these drugs, two slightly different mechanisms of action, but having the same effect on reducing glutamate signaling from that first neuron, was that it managed to reduce checking in our model. Wow. Yeah. And it was within a couple of hours of administration. So that's really exciting for us because, of course.
So sorry, just interrupt. It's on so many levels exciting because it works straight away. I mean, you think of SSRIs, they're like 3 months down the line before it starts to affect.
Yeah, absolutely. So for us, this is minutes, not months. We're really excited by the fact that it's such a fast effect. And we were also really excited by the fact that there don't seem to be other general effects on motivated behavior. So an advantage of the task that we use, the ORT, is that we get lots of measures of ongoing behavior. Because of course, if you give rats an anesthetic and it knocks them out, they'll stop checking. But of course, they're not doing anything else either. That's not particularly helpful. So we can actually use the ORT to look at the impact that it has on their working for sugar, and how much sugar, how many sugar pellets they earn, and how do they discriminate between the levers when they've got the information versus when they haven't got the information, and all sorts of other sort of secondary measures of motivation and motor performance. And we were really excited to see that the effects were selective on the checking behavior. So the animals are able to engage with the task in all of the other ways that all of the animals that don't engage in this high checking do. But what you selectively reduce is their checking behavior.
So it's actually, it's not a blanket approach. It's weeding out the checking, the bit that we don't want in OCD that we're trying to target, sounds perfect. Well, how many doses? You're talking about it works within hours in the rats. How often are you doing this? How many doses? How long does it last for?
Yeah, so we only tested basically acute administration. So what we were essentially doing, we tried different doses within the same animals. Each animal can act as its own control. That's great from a statistical power point of view. So we were only using single doses and then looking at the impact a couple of hours later. What we haven't done, and we need to do in follow-up studies, is to look at the impact of chronic dosing. So if we were giving this every day, how would that affect checking sort of over and over again? We did look at checking the next day. And so once the kind of acute effects of the drug had worn off, the checking the next day was back up to the same levels that it was before. So I think this is something that would need to be given as kind of a daily treatment. But we need to look at the longer term effects and sort of the chronic dosing effects.
And what are the drugs that are being administered? Is it something that most people would know, or it's not like aspirin, is it? It's something probably with a very long name.
Yeah, they're all kind of number plate drugs. So one is called AZD8529, and the other one is LY404039, also known as pomeglumatad.
Both versions are very catchy.
both kind of registration plate, drug names.
And how are you administering the drugs with the rats? Do you give them a tablet, or what is it that they have?
Yeah, so we've been giving them injections actually. So often in animal studies, we will give an injection, whereas, in humans, of course, we would give these orally. So these are sort of systemic treatments. So we're not targeting particular brain regions. It's just going into the animal, sort of into the bloodstream. We wait a couple of hours and then we test the effects on behavior.
Yeah. So just a message to everyone watching, please get your questions in. I will be putting them to Amy. I'll probably put quite a few of them later on, but actually we just have one in now. This is actually from Orchard OCD. So this is the people who host us. So I've got to get this one in straight away. So they say a person with OCD has insight that the behavior is not helping, and then in brackets, or actually being negative, but may feel the urge to do it anyway because of the chemical imbalance. Do you get that question? I don't know. Is that a question?
I think it's a more of a comment than a question, but that's absolutely right. So there seems to be this disconnect in OCD, which I think is one of the things that make it such an interesting condition, is that there is really good insight in OCD that these behaviors are not helping, they're not adaptive, and if anything, they're having a negative impact on the person, and yet there's still this inability to stop. And that's absolutely fascinating from kind of an academic scientific perspective, but it gives us a target potentially as well in treatment development.
It is, isn't it, actually? So someone might say, I know this isn't helping me cleaning my kitchen worktop with bleach for the 10th time, but I have to do it. That's the power of glutamate GABA imbalance. Even though even the other part of your brain is saying this isn't really working, you still do it.
Yeah, it's this must do in compulsive conditions. That's absolutely fascinating.
So that's really amazing when you talk about rats. It's like I do doing quite a few of these interviews with the OCD conversations every month we do, and I just think, wow, this needs to be brought out. We need to be doing this. But of course, you haven't tried it in humans, have you? And if not, what's the next stage?
Yeah, so we haven't tried in humans, but there are efforts underway to raise funds for a clinical trial. As I said, these drugs have been safety tested in humans, so we know that there is possibility of administering them to humans. I think there are many different next steps, depending on kind of basic scientific questions versus sort of treatment development. So I think the next stage from a treatment development perspective would be an experimental medicine trial. So essentially small scale testing whether these drugs have effects on checking in a small number of people with a placebo control, double blind, so that we can't influence the results.
So that will make sense to anyone in the scientific world, to someone who doesn't really know how these drugs are trialed and whatever. You talk about placebo, you talk about double blind. Can you just explain some of that?
Yeah, sorry. So it's really important, I guess, for human trials that we don't want people's expectations of treatment working to make a difference to the outcome of that treatment. So if placebo effects can be really strong in mental health conditions. This has been
believing that it's
believing
working,
that the drug will work. Yeah.
Yeah.
So this has been sort of something that's been really well documented with antidepressants, for example. If you believe that the treatment will work, then often you will start to find improvements in mood, even if you're on a placebo, which is basically a sugar pill, essentially. So we have to sort of control for that. So essentially what you do in these trials is the people who are participating don't necessarily know whether they're getting the actual treatment or a sort of a sugar pill treatment, but everybody gets a tablet. So everybody is expecting that they are taking something, but they don't know if it's the active medication or not. So that's a single blind trial. But there's another possibility as well that, if we're being really rigorous and gold standard scientific, we also have to control for, which is the people running the experiment, if they know who's getting which treatment, that might influence even unconsciously the way in which they're interacting with the people in that experiment. And so you don't want this unconscious bias of knowing, oh, this person's getting the treatment, so I'll unconsciously influence the way that I talk to them or the way that I ask them this question or whatever. You don't want that to influence the outcome either. So the gold standard is a double blind trial where there's one person who has the list of who's getting what, and that goes into a filing cabinet and is locked away until all of the data are collected and analysed. And only at the end do you get to know who got what, and then you can actually see if the effects are real.
That's brilliant. It's like some sort of spy thriller, isn't it? So nobody knows. It's great.
Nobody knows, just the one person with the key to the filing cabinet.
I mean, it's not for this podcast, but just this idea that if you're administering the drug and you know that it's not the placebo, it's the real thing, you might behave differently. That's quite fascinating that that people would do that. But so it would be a double blind, as you've explained, trial. How many people? You said it's a small sample. Is that like 10
probably
or is that
small?
100?
Yeah, small stuff. Probably sort of in the region of 100. So it would be a relatively small trial to start off with. You need enough statistical power to see if you've got effects, but not too many people to start with, because obviously we don't know if the treatment will work or not. And just to reassure any listeners as well, with these trials, if it turns out that the treatment is effective, generally what happens is after everybody's unblinded and everybody knows who's got what, the people in the placebo group are then generally offered the treatment if it's proved to be effective in the group that were receiving it.
And the 100 people, would they all have diagnosed OCD, or is it just a random group of people and 3%?
No, ideally it would be with people who are diagnosed with OCD. So this would be a perfect opportunity for the Orchard OCD registry, which I will plug as well.
So that's something that Orchard, who are hosting this with Made of Millions, charity in the United States, Orchard have a registry of people who have OCD. I'm not explaining to you, Amy, I'm explaining to anyone who didn't know. So people who have OCD can sign up, and it's really well worth doing. Go to the website, the Orchard OCD. I think it's orchardocd.co.uk or something like that. But if you Google it, you'll see, and sign up to the registry. And it doesn't mean that you're going to suddenly have researchers knocking on your door. You obviously have to agree to it, but you may just, help someone like Amy, lots of other people doing trials in OCD that I guess before you probably found it quite hard to find people. And this is just lots of people you can contact who would have, and they will probably list what type of OCD they have, what things they struggle with and what they find easy.
Absolutely. I mean, the registry is such an amazing resource for researchers because recruitment is really hard. I mean, OCD, affects sort of 1 to 3% of the population. So it's not, it's not something you can just walk out of the door and find people who have OCD, especially if you're bringing people into the lab. It's difficult to recruit people, but actually having the registry, and the registry works the other way as well. So studies are advertised on the registry, so people can sort of contact researchers to say, I am interested in participating in this study. So it kind of works both ways in terms of recruitment.
Yeah. I've had a message from Orchard OCD. The link for the registry is above. Please consider signing up. And I said, I've got some sort of set up. It's called StreamYard, and I can't see it above. But I think if you're watching this on YouTube, it is above. Please consider signing up. And as I say, it doesn't mean you'll sign up and then the next day you'll have like 10 Amy's knocking your door saying you have to do this. It's all above board, and you will have to agree to things. But you may actually be helping people, helping find a new really good treatment for OCD. So Amy, can we just go back to the specific areas of the brain? You're talking about glutamate and GABA is all over the brain. That's sort of the thing that drives the brain. And am I saying this right? The neurons connecting with each other. What's happening in OCD? Where's the GABA and the glutamate imbalance that seems to be happening when someone is struggling with OCD?
Yeah. So I'll take one step back and to sort of think about different brain regions. So we have lots of different brain regions that are all supporting different types of memories and different types of behaviors. And we know that one part of the brain that's really important for habits is a particular region of the brain. It sits sort of in the middle of the brain, sort of underneath the overlying cortex, which is called the striatum. And that has really rich connections with other parts of the brain, like the cortex. So the cortex is something that's really expanded in humans compared to animals, but actually just sort of bringing in the rat model again, these same basic structures of having the striatum and the cortex. And there's this wonderfully named corticostriatal thalamocortical loops. It's a good one for Scrabble. So there's a dysfunction in the balance between these loops. So normally these loops can work with the cortex, and the cortex can modulate what's going on in the striatum. So, as we practice particular behaviors, we often find that well-rehearsed behaviors become habitual. Habits in themselves are not bad because they kind of free up cognitive load. If we can do things on autopilot, so long as we have control over when we express those habits and when we don't, habits are absolutely fine. So there's a lot of kind of crosstalk between the striatum and particular parts of the cortex. Now, we know that some regions of the cortex that are particularly implicated in habits are regions like the supplementary motor area, which sits just around here, just in front of the middle of the brain, and regions like the anterior cingulate cortex, which sits sort of just underneath that. There are analogous regions in the rat. They're not as complicated as they are in humans, but the rat also has sort of analogous regions as well. And the work that I talked about earlier from Trevor Robbins' group has looked at the release of glutamate versus the release of GABA in these regions, so particularly the supplementary motor area and the anterior cingulate cortex. And they seem to show excessive glutamate that correlates with the amount of checking that someone is showing when they're in the scanner.
So, but how do you know that if it works in rats, it's going to work in humans? Given that you talked about the frontal cortex being much bigger in humans.
Yeah, so it is much bigger, but we can look for kind of analogies between the rat and the human. So the human prefrontal cortex is massively expanded compared to the rodents, but they do have analogous areas to the supplementary motor area and to the cingulate cortex as well. So we can look at things like, how do these regions connect up to the striatum, for example? That's one way of defining these regions in the rat versus the human. You can also look at all kinds of different ways of classifying bits of the brain. So you can look at what the cells look like, how they connect to other regions. A whole host of things, but we can infer from the animals at least that they have analogous regions to these kind of expanded cortical parts of the brain in humans. But this is sort of one of the challenges of translational testing, because obviously a human is not just a big rat.
Well, some people are, yeah.
So there are potentially differences, but we think for this kind of conserved compulsive circuitry that there's enough similarity there that it means it's worth testing in humans.
Yeah. So what does it tell us about the neurology of OCD? What is happening? Is that the answer to that? Just that the GABA and glutamate balance is not right when OCD is taking hold?
I mean, what it suggests is that this kind of habit circuit is becoming kind of overly dominant, because we know there are other parts of the brain, particularly parts of prefrontal cortex, that help with the control of this habit system. So we're really just focusing on one part, which is kind of the habits becoming out of control. You can kind of imagine, if you like, that you can imagine that we have kind of a habit system, and we have kind of what we probably call a control system that relies on particular prefrontal regions. And you can get an imbalance in these two systems in multiple ways. It could be that the habit system comes up massively and is far too active for the frontal cortex to be able to control it. Or it could be that the frontal cortex is not active enough. So a normal habit system becomes abnormal because the frontal cortex can't control it because it's not working so well. Or it could be a little bit of both. So we're really focusing on that kind of overactivity within the habit system, which is not to say that's the only mechanism in OCD, but it's one of the mechanisms that's really important.
So Simon W has messaged in, and actually it's really good when you get people, viewers, listeners sending me messages, because actually I probably forgot to ask this when we were talking about the trials in humans. How far away are clinical trials on humans? You talked about the size possibly being 100, the double blind, or talked about all those things, but when would that start? Because someone who maybe is struggling today is listening to this thinking, this is a game changer potentially. Why can't we just roll it out quickly? But tell us about the trial, and tell us, if the trial is successful, when we might see this being used on humans right across the country.
Yeah, so the main thing at the moment is fundraising, because as you can imagine, clinical trials are really expensive. So the main thing now is fundraising. So if we can get the money in, and I believe that Nick Sirio, who's the CEO of Orchard OCD, is fundraising at the moment. If the funds can be raised, then it's simply a case of actually getting the trial underway. So we'd have to go obviously through ethics. That will take I would anticipate probably somewhere between 6 and 12 months to go through ethics. So obviously everything has to be ethically reviewed before anything can be done.
What do you mean? And what way? So just that you're altering the brain, that it's actually ethically correct that you're doing that?
Absolutely. So making sure, of course, that everybody is giving informed consent. They know all of the potential adverse effects that taking the drug could cause. All of the kind of making sure that there's no incentive or implication that, particularly if people are being recruited, via the NHS, although hopefully we would avoid that. But if people are being recruited by the NHS, you don't want there to be any implication that, if you don't sign up for this trial, your doctor wouldn't give you the same treatment or standard of care that you would get if you did sign up. So, we have to be really rigorous with the ethics to make sure that everything is above board. So that, that takes time, as does recruitment. But I would hope that we would be able to get a trial going within years rather than, decades.
Like as in next year or in 2 years?
That would be amazing. Next year would be amazing. It all depends on how quickly funds are raised and how quickly we can get through ethics.
Yeah, we've mentioned Trevor Robbins a few times, and it makes me think we need to get him on this podcast. But also Nick, you mentioned there, he's sort of the daddy of Orchard. I think he'll like me saying that. I hope so. So he is the one. I mean, I'm a trustee of Orchard, and he is the one who's driving a lot of this stuff and has driven it. Yeah. And I remember meeting him many years ago and thinking, this guy is doing, could be potentially doing some amazing stuff. And Orchard has done some really good stuff. We talked about the registry. We talked about funding some of the projects that you're doing. If Nick came to you tomorrow and said, I've got the money, we're talking still 2 years before you probably could start a clinical trial.
Possibly one, depending on how quickly it would move through ethics. But yeah.
I'm putting loads of pressure on you. When you also mentioned that in the ethics stage of things, you have to make sure people are aware of the side effects. Are there side effects? What are they? And how many people would they potentially affect?
Yeah, so I mean, there were some side effects reported in the trials for the schizophrenia. Most of those were fairly mild. So often with drugs, you'll get things like headaches. That doesn't affect that many people, though that's a more common side effect. There were some sort of gastrointestinal upset symptoms, I think, were kind of the adverse effects of these drugs in the schizophrenia trials, but that was kind of the extent of it. So they are well tolerated, they are safe. And I think, it's always a weighing up of sort of harms versus benefits. And I think the impact that these drugs could have on someone who's trying to manage OCD versus a bit of a, tummy upset, I think many people would be willing to accept a tummy upset if it had strong effects on checking. Yeah. But of course, you have to let people make these decisions themselves. We can, it's fine for me to say, I'm sure people wouldn't mind, but of course that's down for each individual person to make that decision.
Yeah, totally. I mean, it's OCD. I having experienced it in my family, I realized that it's so trivialized, and it's sort of the poor relation when it comes to mental health funding, and mental health illness funding or treatment funding is the poor relation when it comes to physical health. And actually, this sort of stuff could really change things, but people have to make the decision themselves. I get all of that. So
absolutely.
That totally makes sense. And we're talking about a couple of years' time. I mean, I don't know, Simon, I don't know if you can message again, Simon W, who sent the message in. I guess I'm hearing something that is potentially so amazing. And when you say 2 years, and I know this is what this will happen just for the clinical trial, I see my heart sinks a little bit, because I'm thinking, gosh, there are so many people out there who maybe in 10 years' time, this will change their lives. And yet we have to wait. And I know why we have to wait. How long after the clinical trial do we have the potential for people to be doctors to be giving this out?
I mean, that's a very good question. So I will say I'm not a clinician. I'm a basic academic scientist.
Not basic, Amy, not basic.
Fundamental academic scientist.
Crucial.
But then, of course, we get into questions of policy affecting, influencing NICE guidelines. It becomes a much more kind of political decision then. And we're seeing this, other members of the Orchard OCD College, of course, are trying to pioneer other treatments that, might actually actually be having sort of indirect effects on the same regions that we're thinking about. So some of the brain stimulation technologies, for example, might actually be acting through some of these glutamatergic mechanisms, that we're targeting pharmacologically. And of course, the more treatments, the better, I think, because we don't know that every single treatment will work for every single person equally with OCD. And also patient choice, I think, is a really important thing. So some therapies will be good for some people, some will be good for others. But even if we look at the brain stimulation trials, getting those into kind of nice guidelines and affecting policy to, have those available, particularly in the UK, because things need to be available on the NHS. That's a completely separate kind of kettle of fish in terms of actually having that influence.
Yeah. And one of the things when I first met Nick, who, if we mention him again, Trevor and Nick, they're the two names we talk about a lot. When I met him, he was talking about wanting to give clinicians an armory of treatments, so that when someone presents with OCD, you don't just say, here's SSRIs and here's some CBT. That might work for some people, but we're trying to create an armory. So maybe we're going to give them this drug, or maybe they're going to have an ultrasound, or whatever, but there were lots of options. The key thing when you mention NICE, so if you're listening outside the UK, you might not know that, but that's the organization, you'll probably be able to correct me on this, Amy, that decides whether the NHS, so that's where people, we have healthcare here, where, so if you're listening in America, you might not know what the NHS is, but it's basically where we have free healthcare, and NICE will decide whether a drug can be given out by the NHS. Obviously, the cost is key for that. Is the drugs that we're talking about? You mentioned 2 drugs, and they were like registration
number plates.
Are they expensive? Are they cheap? Because if they're cheap, then it's more likely to be rolled out on the NHS here.
So the AZ compound is expensive, but I would say it is cheaper than citalopram.
Oh, okay.
So
citalopram is used for.
So citalopram is an SSRI. So,
I see. Right. Yeah.
Yeah. Fine. So they are expensive, but we might be talking the same kind of ballpark figures as commonly used SSRIs. So although they're expensive, there may be a kind of a case to be made on the basis of the cost. And of course, we know that OCD, it costs a lot in terms of, not only quality of life for the person who's living with OCD, but, it has a huge economic cost as well in terms of, people not being able to go to work. Also, family members, carers having to support the person with OCD, and the impact that it has on their economic value to society, if we're going to frame it in those terms. We know that OCD has a huge cost. So, again, this is all kind of more policy than science, but a case could be made that even if these drugs are expensive, actually it ends up being cheaper to, in the long run, and much better in terms of, quality of life for the person living with OCD if these drugs are available.
And it's interesting you mentioned that. That's another thing Orchard have done. We've commissioned some work to try and find out the cost of OCD on the nation. And I'm terrible with figures. The figure's gone from my head. I don't know what it is. Maybe someone will be able to message him. But if you go to the website, the Orchard OCD website, you will see. And it's in the billions. I'm sure it's something like £10 billion a year. So if we can help half of those people with OCD, we can really make a difference, not just for those people with OCD, but for the whole nation. And that would apply to anyone living in whatever country you're in around the world. So I feel like it's really important to work out whether, probably you need to sort of say no to this. Can someone just say, I'm going to go to the chemist and buy glutamate or GABA supplements? Is that something that is possible? And that sounds like it. I'm asking that, and I'm thinking that sounds really dangerous because it's not being monitored. Is that something that we need to just sort of clarify if someone's watching and thinking, I could do that?
Yeah. So, the sort of the GABA drugs that people will have heard of are drugs like benzodiazepines and barbiturates and so on. I would definitely not recommend taking those outside of medical supervision, particularly barbiturates. There is quite a low dose is toxic. So, I would definitely not be advising that. I don't think that glutamate supplements are available in the UK. They may be available elsewhere, but I would definitely say, don't don't be going and buying things online. This is, these treatments have been tested in rodents. We haven't yet tested them in humans. We need to do proper, rigorous, trials to be sure that the harms versus benefits, that equation is in the right direction, and that the benefits outweigh any kind of harms. So, I would strongly recommend that anybody listening who is currently on medication sticks with that medication and doesn't think about changing it without consultation with their doctor.
Yeah, right. That's good advice. Just need to clear that up, just in case people at home are thinking that they could take this into their own hands.
Yeah.
I have had a message with the figures. I know we're running out of time, Amy, but I just want to do this because I've got a few more questions to ask you. So, Orchard OCD said the base case analysis estimated the total annual cost of illness, and it's put this long figure that I'm trying to work it out: £378 million to the NHS, rising to £5 billion. There's a lot of figures there, but I think that's 5 billion when it comes to societal perspective. So per year, it costs the UK OCD costs £5 billion. But that's lost days in work. That's the treatment cost. I mean, that's a huge amount of money for a country the size of the UK. And you're talking about treatments that could make a difference, could make a dent into that. So when you're saying the drugs when I'm asking whether they're expensive, I get it. That balance is, it might be expensive, but it's a lot cheaper than the £5 billion. Why I'm interested in why you've got into this line of work, Amy. Did you just sort of start out doing research and then you worked your way into OCD, or do you have a personal interest, a sort of a desire, a sort of call to arms to do something and tackle OCD?
So I think I came into OCD actually from a very kind of convoluted perspective. I've always been really interested in compulsive behaviour. So actually I started my academic career during my PhD looking at drug addiction, which of course is a very different type of compulsive disorder, but with some commonalities in terms of sort of underlying circuitry, but obviously a very different route into compulsion, and very different in terms of insight and sort of impact of environment, although maybe not so different in terms of impact of environment, but they're clearly very, very different disorders. But I think one of the things that sort of drew me in with OCD was the fact that there is this profound insight that you don't see in many other mental health conditions. So, people with OCD are fully aware of the fact that these compulsions are not helping. They are really problematic, and yet they still can't stop. So I just find that absolutely fascinating. So it's a sort of, it was kind of a convoluted route. It's kind of this common interest of, compulsive behavior. But I've ultimately landed on OCD as just being such a fascinating disorder. And of course, the impact that it has on people who are living with OCD is really, really profound. So the idea that we might be able to, in the course of sort of satisfying our academic curiosity about how this works, actually develop new forms of treatment, I think is a really nice, one of the really nice things about behavioural neuroscience is that you can simultaneously address questions of mechanism, sort of fundamental mechanisms of how the brain works, but at the same time be identifying routes where you might be able to develop treatments alongside that.
So where do you want to be with all of this in 10 years time? You look very young, so I'm sure you've got another 30, 40 years of your career, but where would you want to be? Would you want to be talking, say, if we're doing this interview in 30 years time, I probably won't be alive then, but would you be saying, we sorted out glutamate and GABA and now we're on to something else? What's the aim?
So my long-term aim, so I think it would go in two very different directions. One very translational and treatment focused, and one kind of more basic fundamental neuroscience. So from the translational perspective, it would be amazing if this gets through a clinical trial, it works, and there is a treatment available that people can use. Like, that would be phenomenal to know that these experiments that started off, putting some rats in some boxes, working for sugar, then ultimately lead to a medication that people can take. That would be amazing. What would be even better would be if we could then also look at other forms of treatment as well, because I do think it's really important to have a range of treatments, not only for sort of preference of people, because for some people behavioural therapy is their preferred route of treatment, and and that works for them. Other people, it's pharmacological treatments. For others, it might be a combination of the two. What would be even better if we're shooting for the moon? I'm just gonna, my dream scenario.
Well, yeah.
My dream scenario would be that we could actually identify who's going to benefit from which type of treatment straight away.
So you have that armory, but you know that
you have the
person's going to
armory,
be this,
and you have a way of identifying who is going to benefit. Because at the moment, the stats for the onset of symptoms to diagnosis for OCD is typically about 10 years, I think. And then it's generally another couple of years on average to find a treatment that actually works. So from the onset of symptoms to actually having an effective treatment, you're probably looking at 12 years. And that's a huge amount of time and a huge amount of suffering and, loss of life quality for somebody who's living with OCD. If you could have a way, first of all, getting faster diagnosis would be, a way of massively reducing that gap to effective treatment. But if you had a way of then screening people to say, actually, this is the very specific subtype of OCD, and this is why you have this type of OCD, and so this means this treatment will work, that would be phenomenal. So it's kind of analogous to what was seen in cancer medicine. So it used to be the case that there was a set form of chemotherapy. You would try this, and you would try this, and you would try that, which is essentially what we do with the NICE guidelines at the moment. You try this, then you try that, then you try that. But actually now, if you have a cancer diagnosis, you get genetic screening. There's all kinds of things where doctors can identify this is the treatment that is most likely to work for you. And if we could be in that situation with mental health conditions and with OCD, that would be amazing. So my blue skies, my wish list.
aim big.
Yeah, aim big.
So a couple more questions. We're running out of time, but I just want to get through them. Margarita, who I think you know really well, she's one of your PhD students. If you had unlimited funds at your disposal, which studies would you do right away? Kind of like the question I was asking before, but more specific about what if you could just suddenly had loads of money. Orchard suddenly said, we've got £1 billion. What do you want to spend it on? And he said, what are the first aspects you would like to explore that are still not entirely clear?
So, I think funding a clinical trial for the mGlu drugs would be kind of very high up my list, as I'm sure you've already got from this conversation. I think I would also fund the work that Margarita is doing for her PhD. So she has been really, really interested in the intersection between OCD and trauma. So actually my lab, we look at memories in neuropsychiatric disorders. So we're not specific to OCD. We're actually also really interested in post-traumatic stress disorder. We have a whole line of research that is separate there. But what Margarita is doing is bringing these two lines of research together. So she's particularly interested in the interplay between trauma and subsequent obsessions in OCD. So I would love to know more about that, and also whether some of the treatments that are being currently tried for trauma. So Emily Holmes' work with the she calls it the competing visuospatial intervention, but essentially it's playing Tetris in a very specific way, seems to have an impact on flashbacks in OCD, in PTSD. So the question is, would that also have an effect in OCD as well? So I think that would also be high up my list, these kind of more behavioural interventions too.
Yeah, and that's for another podcast. But I have heard that about so Tetris. Basically, people playing Tetris in a certain way can help with PTSD. That just like this, it blows my mind. Chris has said, "Hello. Are any current drugs that impact glutamate, like memantine, lamotrigine, have I got that right, or NAC, worth trying now for OCD?"
So I think not unless under medical supervision. So not as kind of not trying, just because they're available. I do think that there are some really interesting questions that could be asked though. So I think I alluded to Caroline Rodriguez's work with ketamine earlier. that's kind of targeting the glutamatergic system in quite a different way. N-acetylcysteine is targeting it in sort of another way again. There have been trials of N-acetylcysteine in addiction. So I think there could be some scope for looking at those kinds of mechanisms within OCD as well. So I think there's a whole host of kind of fundamental neuroscience studies that we could do, particularly around kind of looking at kind of what's optimal in terms of targeting the glutamatergic system.
And I think we probably need to wrap it up there. Just wanted to say a few messages. So this is, I actually worked out that you can actually put the messages on here. I've forgotten about that. Margarita said, amazing interview. Thank you, Amy. So proud to have you as my PhD supervisor. So you'll be giving her full marks for her PhD next. Simon W, who sent the message in, fantastic, Amy. Thanks for all the work and giving us real hope for the future. And I think that's sort of where I think we always end these OCD, Orchard OCD, OCD conversation podcasts thinking about that, because there are people whose lives, as you've alluded to throughout this, they're being destroyed. You know, I talked about it being trivialized, but this is something that, you know, is so debilitating. And I've learned that it's as debilitating as any physical disability, and it destroys people's lives. And so when we're hearing stuff from you, from other people who are at the, you know, right at the forefront of trying to change things, that in 10, 20 years time, they will look back and say, gosh, that was the spark that brought us this or that and changed people's lives. Does that make you feel, does that drive you on? Or you do this anyway, I suppose, but does that make you feel, I don't know, a bit soppy inside that actually you're doing some really amazing work?
I mean, it would
changing lives potentially.
It would be, I mean, that would be the dream, to have something where, you know, somebody, a doctor can write a prescription and you can think, actually, like, our work contributed to that's the dream. And, you know, if it makes a difference, even if it makes a difference to just a few people, it would be amazing. But, you know, I think there's scope. I mean, we'll have to see, you know, how the research unfolds with, you know, with subsequent trials and, you know, clinical trials and so on. But I think if it can make a difference, that would just be amazing.
Well, thank you, because it is amazing what you're doing, and hopefully you'll get to the end of the road and there'll be something amazing at the end of it that changes people's lives. So Amy, thank you very much. It's brilliant. It's such a pleasure to talk to you. I mean, I was saying at the top, we're talking to some of these groundbreaking people. You're one of them. And it's such a privilege for me to be able to pick your brains for an hour. I just get an hour with an expert talking about something that they're doing that is so potentially so impactful. So thank you so much. And everybody who has been watching and listening, thank you so much. We will be back next month with another fascinating interview on the OCD Conversations. Thank you very much indeed.